Okay, so once again, when you have the absolute value less than something, it is an AND statement, so you're going to shade in between those boundaries. For our next example, we're going to do one where the absolute value is greater than. So let's do x minus, I think we're on example 5. X minus 3 is greater than 1, so absolute value of x minus 3 is greater than 1. Again, 1 is going to be our boundary. Okay. Now this is an OR statement. So we have this as our top boundary. So remember, x minus 3 is going to be greater than 1. So if I was kind of sketching this out, this won't be the actual thing, but x minus 3 is going to be greater than 1, so everything will be shaded up that direction. And then it's also going to be less than negative 1, so we're going to shade it out in that direction. So the statement looks like this. Absolute value, sorry, we actually take out the absolute value now. So x minus 3 is greater than 1, or x minus 3 is less than negative 1. Okay, set up just like that one I did earlier. I think it was example 3, where I said absolute value of x is greater than 3. We set up that OR statement. It's going out in either direction from both sides. Now we solve for x, so add 3 to both sides, so x is greater than 4, or x is less than 2, and now we can make our graph. Our boundaries are 2. Okay, here we go. We have 4, we have 2, we got 0 somewhere to the left, and x is greater than 4 and less than 2. Now that I'm looking at this, I see that I may have kind of reversed it. So x minus 3, oh yeah, we were okay. So x is greater than 4, x is less than 2. Naturally, you'd want to double check to see if these make sense. So you can plug in a 5 here. 5 minus 3, that's 2. So yeah, you are greater than 1. You should try to plug in something over here. So like a 0 to the left side. So 0 minus 3 is negative 3, absolute value of which would be 3 is greater than 1. And try plugging in something in the middle like 3. 3 minus 3 is 0. 0 is not greater than 1, so we can feel pretty confident that we've graphed the correct thing. Now the book has a slightly different way of talking about absolute value. They talk about it in terms of distance. So when you say something like absolute value of x minus 4 equals 2, they're saying the distance between x and 4 is 2. And so on a graph, you could say, well, here's 4, okay, and the distance between, okay, x, right, and 4 is 2. So what they're saying is between here, oops, I didn't draw that very well. Okay, let's try that again. So the distance between here and here is 2, right? Or the distance between here and here is 2. And so if you were to add 2 to 4, you would get 6. And if you were to subtract, you would get 2. So you wouldn't actually put the x there at all. You would just write the 6 and the 4, or 6 and the 2. And you can plug that in and see if that makes sense. So 6 minus 4 is 2, so that's obviously correct. 2 minus 4 is negative 2, and so that would also be correct. So when you're thinking about that in terms of absolute value, if I wrote x minus 5 is greater than, let's start with the less than, is less than 3, what it's saying is the distance between x and 5, so if we were to graph that, we would write a 5, oops, let's close that. No. Get out of there. Let's delete that. All right, that was exciting. Okay, so if we had the absolute value of x minus 5 is less than 3, what they're saying is the distance between x and 5 has to be less than 3. So if we put a 5 here, and x has to be less than 3 spaces away, so that leaves 8, and it has to be less than 3 spaces away on this side, which is 2, and these are boundaries. So if you look at the shaded region, these all will work because the distance between x and 5 is less than 3. So for instance, at 7 minus 5 is 2, that's less than 3. Or at 3 minus 5 is negative 2, absolute value 2 is less than 3. So anything in this shaded region fits using that distance model. That model also works for greater than. So if I said the absolute value of x minus 6 is greater than 4, if we were to graph that, we can say the distance between x and 6, so 6, is greater than 4. So 4 away from 6 would be 10, and we need everything greater than that. Okay, and the distance between x and 6 on the other side is greater than 4, so that would be 2. And that distance has to be farther than 4 away, so we're going this direction. Okay, so you might want to think about it in the terms of distance away from the number. The only time that messes with my mind is when it's an addition problem. So if it looked like this, x plus 2 is less than 5. Notice in the previous 2 examples, or 3 examples, I was talking about the difference, or the distance between, right? Because when you talk about subtraction, you're often talking about the distance between these numbers, like 10 minus 6. The distance between 10 and 6, or the difference between 10 and 6, is 4. So that all works for subtraction, but with addition, that doesn't necessarily make sense. So what you would need to do is you want to turn it into a subtraction problem. And here is kind of the reason why I don't use this technique, but if it makes sense to you, you should use it. So again, the distance, so it was an addition problem. We want to change it to a subtraction, and then it should make sense. So the distance between x and negative 2, so negative 2 is our middle number here, is less than 5. So 5 away from that on the right would be, I think, 3. 5 away from it on the left would be negative 7. And we want that distance from between x and negative 2 to be less than 5. So less than 5. And over here, less than 5. And again, you can plug it in and see if it makes sense. So try negative 6. Try something like negative 6. Negative 6 plus 2 would be negative 4. Absolute value, which is 4, is less than 5. That works. If you plug in something like 4, 4 minus negative 2, or 4 plus 2 is 6, which is not less than 5. So that wouldn't make sense. Okay. So you can either go by the initial few or 5 examples that I gave you, or you can go by more of the book style, which is distance related. Your choice. For your homework, I would like you to do problems on the wrong page here. Here we go. I'd like you to do problems 5 and 19. Problem 5 looks like this. Absolute value of n minus 4 is less than or equal to 1. Problem 19 is somewhere. Absolute value of y plus 5 is greater than 8. Alright, so turn those in for homework. Have a nice weekend. and I'm going to watch Revenge of the Titans.